Pure Handbook 1, Video 2, Surds. Before we begin talking about surds, I want to go through the definition of what a rational number is and what an irrational number. To put it simply, a rational number we can write as a fraction. So 3/4 or 5/2, these are rational numbers. Also, the number 2 is a rational number because you could write that as 2/1. -3 could be written as -3/1. And also 0.6, because that's just 3/5. So rational numbers can be written as fractions. Irrational numbers can't be written as fractions, and the most famous rational number that you probably know of is pi. Now, pi has infinite number of decimal places, and it's not ever a recurring decimal either. So there's infinite digits after that decimal place. It cannot be written as a fraction. But also, we could include other rational numbers such as the square root of 2, the square root of 3, 1 plus the square root of 6, or the cube root of 5. These are also irrational numbers. Whilst if you put them in your calculator will round them to 9 or 10 decimal places, the digits still never have a reoccurring pattern. So these are all irrational numbers, but these numbers in particular, with the square roots, so when I've got the roots here, these are the surds. And this is what we're going to focus on in this lesson today. Now, in your handbook, there is some questions to have a go at in terms of some true or false statements, and also ones where you've got to put an equals or not equals to sign. So have a go at those first and then come back and have a watch of this video. So hopefully you've had a go at some of those questions. I just want to talk about some of the common mistakes people make with surds. Now, we all know that 9 plus 4 equals 13. But notice that the square root of 9 plus the square root of 4 does not equal the square root of 13. Similarly, if I take something like, let's say, 13 take away 6 equals 7, well, notice that if you put in your calculator the square root of 13, take away the square root of 6, does not equal the square root of 7. So, a lot of people are fine with that fact when I put it as numbers. However, when we introduce the algebra, so you have a plus b equals a plus b. I'm going to do it like this. Now, if I square root the whole of the right-hand side, but only square root the first two terms here, well, by looking at what happened with the numbers there, the square root of a plus the square root of b does not equal the square root of a plus b. As I mentioned before, when it's with the numbers, people are quite willing to accept that, but with the algebra, that's where the mistakes make. When we square root both sides of an equation, we need to make sure we square root the whole of the left-hand side and the whole of the right-hand side. We can't just square root individual terms. And I think the mistake people make there, and why they make that mistake, is because when you multiply, you could multiply individual terms, but you've got to be very careful with the square roots. This isn't only square rooting that it's applied for, it does also apply for squaring as well. So it's something to watch out for. Again, 9 plus 4 equals 13. That doesn't mean 9 squared plus 4 squared equals 13 squared. And there's other mathematical functions that will also be the case with that you'll find out in due course. Now let's look through the rules of surds. This first one here on the left, if I have a number such as square root of 10, I could simply write that as square root of 5 times the square root of 2. Okay, so square root of a times square root of b just equals the square root of a times b. So a very important rule that we're using quite a lot. If you have something like the square root of 21 over 7, that is just the same as the square root of 21 over the square root of 7. So you can just square root top and bottom there and divide, and it will still give you the same answer. Finally, if you do something like the square root of 3 times the square root of 3, that will just simply equal 3. Let's put these rules into practice then. Looking top left, square root of 12 What I'm going to do to simplify this surd is I'm going to break up the square root of 12 into the square root of 3 times the square root of 4. What we want to do here is find the largest square number that goes into 12. So that's, in this case, it's just going to be 4. Now, the square root of 4 can just be written as 2. So this simply just becomes 2 root 3. Looking at the example on the right, the square root of 40, I'm going to break that up into the square root of 10 times the square root of 4. Yet again, 4 is the biggest square number that is a factor of 40, and then I've got divided by 2 on the bottom. Square root of 4 is just 2. This is 2 root 10 over 2, and the 2's cancel, just leaving you with that square root of 10. You can't break down the square root of 10 any further. It's got factors of 1, 2, 5 and 10, so we can't go any further with that. None of those are square numbers. Looking at this next example, we've got quite a lot of things to simplify here. So let's start with the square root of 75. That's just square root of 25 times square root of 3. Okay, 25 is the biggest square number that goes into 75. For the 3 root 80, we're going to do square root of 5 times square root of 16. You might be tempted to go for square root of 4 there, but then you'd have a square root of 20 that could then be broken down further. The 12, well, we've already seen what happens with the square root of 12. Just break that down to root 3 and root 4. The 20, going to break it down as root 4, root 5. And your 45, break it down as root 5 and root 9. 9 being the largest factor of 45 that is a square number. Now, simplifying these terms, square root of 25 is just 5. Square root of 16 being 4. Make sure you times it by that 3 though for the 12. And then we've got square root of 4, which is 2. Times it by the 2 that's already there. That's going to be 4 root 3. We've got a minus 4 root 5. And then a positive 15 root 5. Square root of 9 being 3. 3 times 5, 15. Times about square root of 5. Then, like we do in algebra, we collect together our like terms. So just like you collect together x's and you collect together y's, or you collect together x's and x squares, we collect together our root 3's and we collect together our root 5's. We've got 5 root 3, take away 4 root 3, which just leaves us with root 3. And then we have this 12 root 5 minus 4 root 5, minus square root of 5 plus 15 root 5. When we add that together, we're going to get 23 root 5. And we can't do anything more with that answer, so we're just going to leave it as that. On to the final examples then. Now we're just going to expand these brackets here. It works just as it would if you were normally expanding brackets. So as you progress through A level, you probably won't need to do your smiley face or whatever you like to call it, or FOIL or your grid method. You should be used to it. But if you still need to do the lines, that's absolutely fine here. So we're going to do the 1 times the 3 first. Then we're going to do the 1 times the negative root 3. We're going to do the root 2 times the 3 for 3 root 2. And then we do root 2 times negative root 3, which is just negative root 6. There's no more cancelling we can do there. There's no other integers than the 3. There's no other root 3s. There's no other root 2s. There's no other root 6s. So I can't break that down any further. Let's look at this other bracket problem then. Again, if you need to draw your lines, do that. So root 5 times root 3, that's root 15. Root 5 times root 5, now, because that's root a times root a essentially, it just becomes a without the square root. So root 5 times root 5 is 5. Think about indices like we did in the last lesson. 5 to the power of a half times 5 to the power of a half, you'd add those powers to get 1. Root 2 times root 3 is root 6. And root 2 times root 5 is root 10. Yet again, there's no more cancelling I can do here. The final thing we'll look at in this video is rationalising the denominator. This is going to be really important that we can do this. Often we'll be asked to leave our answers in certain form. And also I'm aware this is something you can do on your calculators, but what you'll find in A-level is sometimes there'll be questions where it's not just numbers, you have got some algebra introduced, so you would need to know how to do it if everything was in terms of A, for example. Now there's 3 different types of problems that you might find. The first one is if we've just got a surd on the bottom, and what we're looking to do when we're rationalising the denominator is get rid of the surd on the bottom of the fraction. So to do that, if you just have a problem like you do on the left here, you could just simply times the top and bottom by the square root of x over the square root of x. Now, we can do this isn't changing the number in any way, because you're basically just timesing by 1. So it's okay to do this. Now, if you have something like b plus root x, then what you want to do is times top and bottom by b minus the square root of x. What this will do is you end up with a b squared minus x on the bottom of your fraction, and the bx and the negative bx, well, they're going to cancel each other out. And then a similar thing happens if you've got b minus c root x, multiply both top and bottom by b plus c square root of x. I think the easiest way to see this is to go straight into some examples. So example 4, we're going to rationalise, so meaning there's no surd on the bottom of these fractions. Now 2 over the square root of 3, all I simply do here is times top and bottom by the square root of 3. And on the bottom here, square root of 3 times square root of 3, of course it's just 3. And on top you've got 2 root 3. On the right, I'm going to times top and bottom by the square root of 5. On the bottom, we just end up with a 5. And on top, root 3 times root 5, well that's just root 15. And then times it by the 8. No more cancelling we can do there. So now some slightly harder problems. 3 plus root 2. I need to times both the top and the bottom by 3 minus root 2. It's really important that you times the numerator by that 3 minus root 2 as well. Otherwise you're changing the number. Okay, as long as you times both the numerator and the denominator by the same, you're not changing the number because you're essentially timesing by 1. So on the bottom of this fraction, you want to think of this as a bracket of 3 plus root 2 times a bracket of 3 minus root 2. Now 3 times 3, that's going to give you 9. Root 2 times negative root 2, that's going to be minus 2. Careful, common mistake is people might put minus 4 because 2 times 2 is 4. But remember, it's the square root of 2 times the square root of 2, which is just going to be 2. There's no other terms here because 3 times negative root 2 and root 2 times positive 3 are going to cancel each other out. So you could write those other terms out if you wanted to, but they're going to cancel each other out. So in general, all we want to do is just that first term times the first term and then the second term times the second term here, because the other's going to cancel out as long as we've chosen the right thing to multiply top and bottom by. On the top, we're just doing 1 times that 3 minus root 2, so we just have this, and all we simply then do is just do 9, take away 2 for 7. Sometimes we can leave our answer in that form. Sometimes it might ask it for in the form a plus b square root of 2, for example. In that case, just split up your fraction. Finally, we're going to times both top and bottom by root 7 plus root 5. So just changing the sign of what's on your denominator there. So on the bottom of this fraction, root 7 times root 7, that's just 7. Make sure you don't times it for 49 because they're both square rooted, so it's just going to be 7. Root 5 times root 5 is 5, so we've got negative 5. And also remember, root 7 times root 5 and negative root 5 times positive root 7, they're just going to cancel each other out. On the top of your fraction, make sure you times both of these terms by the 4. So we've got, I'm just going to leave this in a bracket and you'll see why in a second. So on the denominator, I've just now got a 2. 4 divided by 2, well, that's just going to cancel down to 2. So I've just got 2 bracket root 7 plus root 5. Or you could expand that out if you wanted to, but there's really not much need to do that here. Hopefully we're starting to get a hang of it, but a couple more examples just to clarify. And getting slightly harder these last two. Now, firstly, when I'm rationalising this, yet again, just do root 5 and you've got root 2, but just change the sign. You've got negative there, so just make it positive here. And also make sure you multiply the top by the same thing. Yet again, people might be put off with the fact that you've got a kind of surd on the top and just change that to a negative. No, make sure that you times top and bottom by the same. And also, whatever sign you've got on the bottom here, that's going to be the opposite sign what you're going to be multiplying by. So ignore what's on the top, just make sure you're rationalising the denominator. So on the bottom of this fraction, root 5 times root 5 is just 5. Root 2 times root 2 is just 2. So it's going to be 5, take away 2 on the bottom. And then when you multiply out the brackets on the top, you're going to get 5. Now, this isn't going to cancel, so make sure that you do multiply this out and get all 4 terms. You've got root 2 times root 5 for root 10. You've got another root 5 times another root 2. It's going to give you another root 10. And root 2 times root 2 is just 2. 5 plus 2 is 7. And then you've got 2 root 10. And then just simply divide by the 3. Okay, 5 take away 2 for 3 on the bottom there. This last example, we can't just times it by square root of 3 plus 1 all squared. That's not going to work. What I'm going to need to do first is expand this out. Now remember, this bracket is squared, so this is the square root of 3 minus 1 times the square root of 3 minus 1. So we're going to multiply this bracket out on the bottom first, and hopefully then we'll have something that we can then rationalise. So root 3 times root 3 is 3. And we've got a minus 1 times root 3. And we've got another minus 1 times a root 3 for minus 2 root 3. Minus 1 times minus 1 is positive 1. When I simplify that numerator, hopefully you can see now, I get 4 minus 2 root 3. Now I can simply go ahead and just times, not by that though, times top and bottom by 4 plus 2 root 3. So on our denominator, 4 times 4, 16. And then we've got minus 2 root 3 times positive 2 root 3. That is going to be negative 12. Okay, minus 2 times 2 for the minus 4, and then the root 3 times root 3 for the 3. And then on top, 3 times 4 for 12, and 3 times 2 root 3 for 6 root 3. So on our denominator here, I get 4. On top, actually what I should have done is, well, what I can do now is, so I've got 12 and 6, they've got a common factor of 6. So then I can just simplify this further. 6 divided by 4, well, that's just can be written as 3 over 2. And I'll just keep this 2 plus root 3 as it is. Exam question time, and like we've seen with indices, the question in the exam might not necessarily just be rationalise the denominator. It's going to be in some more kind of complicated problem solving form like this question. And this question, we're told that m is rational. Remember, rational means can be written as a fraction. And you're asked to find the value of m such that the following fraction here is rational. The first thing we're going to do to start off with is rationalise the denominator. So what I would do is I look at my denominator, there's a 1 plus root 8 there, so I want to times both top and bottom by a 1 minus root 8. When I multiply that denominator, 1 times 1 for 1, root 8 times negative root 8 is going to be negative 8. And then I'm just going to simply multiply the top now. So m times 1, just going to be m. M times negative root 8 is minus m root 8. Root 2 times 1 is just root 2. And then root 2 times negative root 8 is going to be negative 4. That's because root 2 times root 8 is 16. The square root of 16 is going to be 4. Now, I'm going to group together the rational parts on this top of the fraction. So m minus 4 is rational. Okay, you're told m's rational, minus 4 is a rational number. But then we've got this plus root 2 and this minus m root 8. To make it simpler, I'm going to simplify that surd of root 8. That is just simply going to be 2 root 2. Okay, square root 4 times square root 2 makes square root of 8. So that's just 2 root 2. And on the denominator I get minus 7. Now for this to be rational, there needs to be no surd on the top of this fraction. Okay, so to be rational, there cannot be a surd on the top of the fraction. What this means is, this bit that I'm going to highlight now, this needs to be 0. Okay, I don't want any root 2's. So the square root of 2 minus 2m root 2, that must equal 0. So to solve this, what I would do is I would take out the square root of 2 as a factor. Then I have a 1 minus 2m. I can simply divide both sides by square root of 2, leaving me with 1 minus 2m equals 0. And then m would just equal a half. If you want to, you can also then go back and sub that back into your original equation and check that indeed when m is a half, then you do in fact have a rational number, which I believe is it's positive a half when you do put m as a half in there.